Yes, we are going to continue reviewing before we start with each day's work, because when you divide with decimals, it's important where the decimal happens to be or not be so that you know what to do. A couple of quick reminders also: if there's going to be a decimal in the answer, you do not want a remainder. There are some things you will learn in 6th grade as far as what to do if you keep dividing and have to keep on putting zeros and zeros because you subtract and your subtraction shows that there would be a remainder. So there are mathematical steps that you take if it looks like a division with a decimal goes on forever. But what's important for you in 5th grade is to remember you don't want to mix up a decimal and a remainder. Almost always the problems that you get as 5th graders will end after 2 places beyond the decimal, or you will be asked, as this does, to round. So you would only need to go as many places after the decimal as it would take to round, in this case, to the nearest whole number if you were solving them. Procedures for the decimals when they are in the divisor. You always want the divisor to be a whole number, so you need to move the decimal however many places it takes to get that decimal right next to the bracket. The decimal inside is connected to the decimal outside. You can think of it that way. So if the decimal outside the bracket moves once to make it a whole number, the decimal inside the bracket must move once to make it a whole number. This one didn't need to move at all because already the divisor is a whole number, since there is a decimal as part of the dividend that comes right up into the quotient. Here there was 1 decimal place that had to be moved, so the tenths were no longer tenths, but they were a whole number. This did not show you a decimal in the first place. See how I can erase that? So you have to know, even if there's no decimal showing on the inside, if the divisor is not a whole number, if the divisor has a decimal, you must move till the divisor is a whole number, and you have to move the decimal on the inside. Those decimals are connected. Whatever you do to this decimal, you must do to this decimal. In this case, the decimal is implied after the whole number place. Since there was nothing there in the first place, you show that there still is nothing, even though you moved your decimal past that place. 8 was a whole number. The decimal in the dividend came right up into the answer. 7 tenths was not a whole number, so this decimal had to move 1 place, so this becomes 7 whole. The decimal is right next to the bracket. In the dividend, on the inside, the decimal is going to have to do exactly what happened to the decimal in the divisor. Moves over once, comes up into the answer. In this divisor, the decimal, if you only move it 1 place, you have 7 and 2 tenths. 2 tenths is not a whole number yet, so you had to move the decimal 2 places in order to make a whole number. Since this was 74, you can see there was no decimal. We needed to put the decimal in whole numbers. The decimal is always to the right of the ones place because it shows that there are no pieces yet. However, we need those places now, and we need to fill them with zeros, and the decimal comes up into the answer. So now the problem is 7,400 divided by 72. That's a quick review. Now we go into what your answers should have looked like on page 468. You were asked to do number 15, 16, 17, 18, 19, and 20. These are the directions that you were given in the video yesterday. Do divide, do not estimate. So only the answers I'm about to show you would have worked. What I did when I came up with these If I needed to put the 0 after the decimal place so that I had no remainder, I showed you the zeros that I needed to add. So 15 should have come out to be 5 and 15/100ths. I needed one more 0 to make this work out. Remember, I have as many zeros after the decimal as I need, but hopefully in 5th grade division, I don't need more than 2 places after the decimal. In the video yesterday, I told you, well, actually, you were going to need to add 3 more zeros if you wanted to finish this. I told you also it was okay to stop 2 places after the decimal. Had you stopped after dividing by 30, or after dividing 30 by 8, you would have said 3 times 8 is 24. That gets you your 2nd place after the decimal. You would have subtracted. You should have had 6 down here at the bottom. You were not to record that as a remainder. You just sort of stopped your answer at that point. However, if you added another 0, this has you divide 60 by 8. So 7 times 8 is 56. You get a 4. Put one more 0 on here, and all of a sudden, we won't have a remainder because 5 times 8 is exactly 40. So 3 and 375, not thousandths, but 10,000ths is this final answer. You might have had 3 and 300ths. It is important, and this is a place where 5th graders often make errors, right here. When you bring down just a 3, don't forget you still must say, but 0 times 8 is 3. You must deal with each number as it is when you bring it down. Since there was nothing left when I subtracted 24 minus 24, I had to say 0 times 3, or 0 times 8 is 0. That's the only way I can get a subtraction answer that is less than 8. So watch out for those. This one only needed 1 0 past the decimal place. We're going to be working a lot more the next few days with the idea of what happens when you divide by 10 or divide by 100. So in this case, it's kind of interesting. 118 and 1/10 divided by 10 came out to be 1181, 1181. The only difference is here the decimal is so that there are hundredths. Here the decimal is so that it's tenths. So when we divided it by 10, we took these digits but just moved the decimal to make it 10 times smaller. We'll talk lots more about that later, but that should kind of show you a pattern when we divide this one by 100. And yeah, it was not difficult to divide by 100. Remember, the problem called this 10 to the second, but 10 to the second is the same as 10 times 10, which equals 100. So this was the problem. We ended up with the decimal coming up. You only needed 2 more zeros afterwards. This was nice, simple division. That was your final answer. This one I left because I wanted to show you and remind you this was written as 1 8/10 divided, or it was written straight across, divided by 8/100ths. So 1 8/10 divided by decimal 0.8. This decimal has to come next to the bracket so that 8 is a whole number. This decimal must move twice before you can edge it up to the top. You must have a placeholder. Then you just divide through as if this is a regular 8, because it truly is. 18. 8 times 2 is 16. Subtract, get 2, bring down the 0. Still need to use the 2 times 8 again. That's 16. Subtract, got to borrow. 10 minus 6 is 4. Now I'm past that decimal, so I want to show you this 0 is a little bit different because I had to Remember that it was there in the first place, but I bring it down. 8 times what comes close to 40? 8 times 5 is exactly 40. No remainder. Number 20, didn't have to do your 62 times tables very much. Moved the decimal over one place in both the divisor and the dividend. Bring it up into the quotient. Divided through, 2 times 62 was 124. Subtract. 7 minus 4 is 3. Bring down the 1. This answer will go on this side of the decimal, right? You should be able to see that. 0 times 62 is the only way to get something that's less than 31. Then you subtract 31, bring down that last 0 that we had to add so that we don't have a remainder. And 5 times 62 comes out to be exactly 310. There is no remainder. Those are the problems that you had to do yesterday. Now we are going to do some patterns. I was just looking at the the time to see how long I should make this. We will go into your math folder and do the patterns really quickly, and then I'll give you your assignment. So in your math folder, okay, it froze. Good, it unfroze. In your math folder, the most recent page where we have put information should look like this. And at the top you say division with decimals. What we're going to do today is we're going to take these patterns and write them out differently. So we're not doing anything new, we're just showing it in a different way. 35, this time we're writing it across, divided by 5 equals 7. 3 5/10 divided by 5 equals 7/10. Oops. And 35/100 divided by 5 equals 7/100. Then we changed things around a little bit, and we said 35 divided by 5/10. So up here we were always dividing by 5 whole things. In this section we're always dividing by 5/10. That came out to equal 70. When we changed that to be 3 5/10 divided by 5/10, that was just 7. And finally, when we did 35/100 divided by 5/10, that answer came out to be 7/10. So you should be able to look at these and see all sorts of patterns. Now I am going to give myself a little bit of extra space, because remember down here at the bottom I didn't have quite enough space to fit this third one in here, long division. So I'm going to move these things around a little bit. Now we're going to do, the original problem was 35 divided by, before I moved to the decimals, 5/100. That came out to be 700. When we did 3 5/10 divided by 5/100, that answer was just 70. And the final one, 35/100 divided by 5/100 was 7. So these were done long division. Now we have this division written out so that you can start focusing on really seeing what we did. We started with a whole number divided by a whole number, then a little smaller, then really small. What happened to our quotients? Then we switched over to a whole number and we divided by half. We divided by 5/10. And what happened there? Then we only took 5/100ths of whatever it was we started with. So we took what we started with and divided it into really, really, really small piles and got lots of it. Now, what we are going to do, we will need to come back to this page on Thursday, so be ready for that. But today's homework assignment is going to be page 458, so back a little ways, 458, and you need to do only numbers 14, 15, and 16. But do be sure that you show all of your work, your multiplication, and label. These are story problems. As you consider that, some other things to think about. If there's not enough space on the page to show all of your work, there we go, use another piece of paper. There are decimals involved in all of these, so you should not have remainders. We worked a good bit in previous weeks with figuring out what remainders meant. In this case, you should not have remainders. If you come up with remainders, you have done the problems incorrectly. Remember, only 14, 15, and 16, nothing else, but do show all of your work. That is your math for today.